we've done the first half of this unit on solving one-step equations. We did multiplication and division, we did addition and subtraction, we've simplified expressions. Now we're ready to move on to solving two-step equations. So as we solve two-step equations, the important things to remember here are that we're going to want to work backwards. So instead of multiplying and dividing first, you're going to add and subtract first. So you kind of want to reverse your mindset on order of operations. When you're solving, instead of simplifying, when we simplify, we multiply and divide first, then we add and subtract. When we're solving, we add and subtract first, and then we'll multiply and divide. So there's just kind of a change in mindset there. So now we'll go through a lot of examples with this, but you just want to make sure that you're kind of keeping that in mind, that we're working backwards, so that order of operations is almost going to be backwards from what we're used to as well. So go ahead and jot down those couple of notes there, making sure again you have your lesson title and dates and such. Now let's go ahead and take a look at a few examples here. So the first example says 2y plus 3 is equal to 11. So again, keeping in mind that we're working backwards, what we want to do is we want to subtract the 3. So you're still solving, so you're still doing the opposite. So I'm working backwards. So I'm going to subtract the 3 first. So there's just a lot of backwards thinking. This is all topsy-turvy, upside down. So we do the opposite here. So we have the 2y's left. 11 minus 3 gives us 8. Now I still haven't solved for the variable. I still have something attached to the variable. So now I also need to divide by 2. And that's going to leave me y plus 4 as my final answer. So again, two-step equations, we're adding and subtracting first, then we multiply and divide. So keeping in mind for the second one, again, working backwards as well as doing the opposite. We're going to subtract 3. So we're left with 5x is equal to 15. But I still have something attached to the variable. To undo that, I'm going to divide. So I'm left with x is equal to 3. Let you catch up for a minute. Then let's go ahead and do the next one together too, and then I'll give you some to try on your own. So again, this time we have 3x minus 4 is equal to 23. So again, to undo the addition or subtraction here, the subtraction, we're going to add 4 to both sides. Keeping in mind our golden rule, what you do to one side, you have to do the other. So these will cancel, and we'll be left with 3x is equal to 23 plus 4, will give us 27, divided by 3, x will be equal to 9. So all of these are examples of how to work backwards, but while we're working backwards, we're also doing the opposite. So go ahead and copy those down. I'm going to put up some examples that I want you to do on your own here on the board. Alright, let me move the camera. Now I'm going to have you guys go ahead and work on these 3 problems on your own. Try those for a minute or two, and then just like usual, I will go ahead and put up the answers to those problems. Keep in mind doing the opposite and working backwards. So, letter A was a lot like the last ones. I'm going to go ahead and move part C over here, and then we'll move the camera to compensate in a minute. I'm going to give myself some room to work. Alright, so with this next one though, it's a little different because we have a fraction here. So again, starting with our addition and subtraction, we're going to subtract 6 first. Those cancel. We're still left with x over 5 is equal to 11. Now, once we're here, the opposite of, remember, the fraction is division, so the opposite of that would be to multiply both sides by 5. So then we're left with x is equal to 55. So that's the only difference there, is that we're multiplying this time instead of dividing. And then one more. Again, this one will be the same idea, except this time we're going to be adding. So when we add 12 to both sides, we're left with t over 7 is equal to 41. Multiply both sides by 7. And t will be equal to 287. Now, before the end of this chapter, we will start writing these on our own from word problems. For now, when we do a word problem, they will be giving us the solution, or the equation, excuse me, not the solution. But here in the next couple of sections, we're going to actually be writing these ourselves. But for now, I want to do this word problem together. Just so you get an idea. So there's neighbors hosting a party, and each neighbor buys a watermelon for $8. They split cost of paper products equally. Oops, not each number. Each neighbor spends a total of $20. Solve the equation p over 3 plus 8 equals 20 to find the cost of paper products. And the 3 came from the fact that there were 3 neighbors. I didn't write that down, but in the beginning it did say that there were 3 neighbors that host a party. So they each buy a watermelon for $8. The cost of paper products are split equally. Each neighbor spends a total of $20. So then they give us the equation p over 3 plus 8 is equal to 20 because you have the total cost of paper products divided by 3, add on the cost of the watermelon, and that should give them the total of $20 cost for everything there. So take a minute, go ahead and try to solve that. And then again, like usual, I will put the answers up. Put the answer over here on this side. So once you've taken a minute for that, again, keeping in mind with the opposite of adding 8 is to subtract 8. So 20 minus 8 is 12. We multiply both sides by 3 to do the opposite of division. We end up with a total of $36 for paper products. And that is all that's to solving two-step equations. Next time we'll move on to writing one-step equations. We'll stay there for a section or two, and then at the very end of this chapter we'll write our own equations for problems very similar to this one.